Good afternoon, everyone. Welcome back. Thank you for joining us. We're glad that you're here. My name is Steve.
And I'm Scott.
And together, we are Backyard Musing Science and Technology Channel.
Yep, and we're talking about one of our favorite planets, one of my favorite planets anyway, the moon,
It's a
product
moon.
of the 60s. So
Scott, it's a moon. It's not a planet.
it's a planet.
Okay.
Come on. Okay, are you a Pluto denier too? I'm not going there.
So is
Anyway, we're
Deimos.
talking about the moon. Here we go.
A bright new lunar crater detected in spacecraft images shows that asteroid impacts continue to reshape the moon's surface today. The moon's familiar surface tells a story of both ancient violence and ongoing change, while its vast dark basins formed during a period of intense bombardment billions of years ago. New impacts continue to reshape the lunar landscape today. By carefully comparing images taken years apart, scientists can detect newly formed craters and study how fresh material gradually darkens under the effects of space weathering. Would you like to know more?
Hey, do we get to ever see those? Do we get to see those impacts?
Well, I've heard of they caught one recently, an impact, and I thought that was this, but I don't know that it's this. But they caught an impact on the moon, first ever.
They need to get that technology going. That would be pretty cool, huh? I could watch that. I could
Yeah.
watch. For most of its 4.5 billion year history, the moon has been heavily battered by collisions. The large basins that appear as the dark seas forming the man in the moon were created during an era of intense impacts that ended about 3.8 billion years ago. That's when they discovered cheese. So,
Although the period of massive basin-forming collisions has long since passed, the moon still experiences strikes from asteroids and comets that leave behind smaller and relatively young craters.
catching these events as they happen is extremely difficult, like we're just asking. Instead, scientists usually identify them after the fact. Researchers working with a lunar reconnaissance orbiter camera found one such crater by comparing detailed photographs of the same lunar locations taken at different times. By examining images compared before December 2009 and others taken after December 2012, they were able to narrow down when the impact occurred, even though no one actually observed the collision.
The crater measures 22 meters in diameter. What is that? 66 feet, roughly 67 feet, compared to a large house. What makes it particularly striking is not its size, but its brightness. The collision ejected material tens of meters from the crater rim, creating distinctive rays that spread outward in a sunburst pattern. This bright, fresh material contrasts sharply with the surrounding darker regolith, making the crater stand out like a new freckle on familiar skin.
Hmm. These rays won't stay bright forever. Space weathering, the cumulative effect of solar wind particles, micrometeorite bombardment, and cosmic radiation, gradually darkens exposed lunar material. Over thousands to millions of years, this fresh crater will fade until it becomes indistinguishable from the countless ancient craters surrounding it.
This darkening process is why older craters lack prominent rays, while relatively recent impacts like Tycho, formed perhaps 108 million years ago, still sport brilliant ray systems visible from Earth.
Hmm. The discovery of new craters serves several scientific purposes. First, it helps astronomers refine estimates of current impact rates, which is essential for understanding the hazards facing both robotic missions and future human explorers.
Second, by observing how quickly rays darken and crater features degrade, scientists can calibrate their models for dating other lunar surfaces based on crater density and appearance.
For those who appreciate the moon, a planet's geography, there's something rather than wonderful about knowing that this ancient, unchanging face we've gazed at throughout human history continues to acquire new features. The moon, a planet, isn't frozen in time.
It's still being sculpted, still collecting new scars from its journey through space, even if we're unlikely to actually witness an impact on the moon, a satellite. These fresh craters remind us that the solar system remains a dynamic, occasionally violent place.
So if you were on the moon and you were staring at the Earth, would you call the Earth a satellite?
No, because
Or a moon?
the Earth doesn't go around the moon. The Earth is larger, so has a heavier gravity mass, and the moon is smaller, so it satellites around. Mars has a moon. I think it's named Deimos.
But if you were on the moon, would you not see the Earth like we see the moon?
You would, yeah. And like people 600 years ago would say that the Earth is flat and that the sun revolves around the Earth, but that's just fantasy.
But you've told me that there are people a lot sooner than 600 years are still thinking that way.
People still think that way. Oh,
There
I
you
think about Shaq O'Neal. Shaq O'Neal is a flat earther.
No, he's not. Is he really?
Let's have the folks correct me if I'm wrong. Put it in the comments. If I'm wrong, let me know.
I think we should have Shaq on. Talk about flat Earth. So we need a larger camera. All right. Sounds good. We'll see you all tomorrow. Thanks.
Thanks, folks. See ya.
All right. I'll see you in a few.
Yep.